There's three main categories of physical result that show themselves up over and over and over. And again, do not limit it to this. But what are they? The first is that of, I'm going to say the term, we'll get it out of the way, and then we'll think about it just a little bit more. The term is ionizable metallic salts. The physical size of these particles that I'm talking about is at the sub-micron level. It's different whether something is sub-micron or not. It's different whether you can see it or not. What kind of equipment do you need to see it? It's different in terms of classifying something what it is. First of all, sub-micron. What's it mean? Simplest example I can give you is that your hair is on the order of 60 to 100 microns thick. The materials that I'm speaking of here are at the sub-micron level. You're not going to be seeing this with your regular eyeball. The physics of how it affects the atmosphere and the environment are not something you're going to be easily able to get your hands on. We talked about the HEPA filter for a second, and that filter is very commonly, you can buy one of those for 15, 20 bucks. That filter can gather materials down to 0.3 of a micron. Pretty darn remarkable for a $15, $20 piece of equipment. It's a big difference whether something is a micron or 2 microns. 2 to 4 to a fraction of a micron is a huge difference in terms of how it affects our environment, how it affects our respiratory tract, how it affects light scattering. The use of the word nano does not fit with my work. Nano is down there. You're going to need an electron microscope down in the nano world. This stuff is at the micro world. So you have a class of materials that are, first of all, down at this size range. You're not going to be seeing them with the visible eye by any means, and they're going to have some unique properties with respect to light and all this type of thing. But I also mentioned the word ionizable metallic salts. And what does this mean? Man, this one opens up a big world. You start out with metallic salts. That's interesting itself. And by the way, metals are not necessarily uncommon. If you go through the periodic table, roughly half of our elements are metals. So, if you start to dissect what I say, something metallic is not particularly unusual in the environment. Okay? Metallic salt restricts it a little bit further. It starts to suggest, let's say, the solubility, the ability to put something in solution. Right? We're talking about water down the road with our atmosphere. We're talking about water. And so when I start to say metallic salt, now we're getting in an area where we're saying, probably have an issue of solubility for them. And again, to bring it back to simple cases, what happens when you put some salt, a regular table salt, in some water? What happens? And what happens is the slightest bit of salt, you don't need much, the slightest bit completely changes the electrochemical properties of that solution. That salt solution will carry a current. Pure water doesn't carry much at all, almost nil. But you put a little bit of salt in that water and everything changes with respect to the physics of that solution. The ionosphere, many of us have heard of the ionosphere, a layer up there about 60 to 100 miles above us. And what happens there? This is a charged layer. Ion, by the way, means charged. It's a charged particle. It's something that carries an electric charge. What's that mean? It means it has the ability to conduct a current. The ionosphere is a layer up above us, very, very different physical properties. And if you look at that, if you look at the amount of it, it's something like, it's like 2%, 3% of the mass of that. That layer is electrically charged, but it completely changes the physical and electrical properties of that environment. And so when I start to say that we have the repeated detection of ionizable metallic salts, and the expected consequence of that is that our atmosphere, which by all measures is not regarded to be a conductive environment, certainly not highly conductive in any way, generally not conductive. Air is one of the best insulators that there is, right? What happens if you introduce a physical change to that atmosphere that at the very least enhances Degree is always a question, but enhances the propagation of magnetic energy through that environment. What happens? What happens is you completely change the basic physics of this planet. You have a shell. You have a shell around the Earth. There's a word plasma that comes up. I didn't know what plasma was when I started. I was, conventionally trained, and so I dig in when I need to. I didn't know plasma. Plasma was Star Trek to me. Okay. If you actually dig into it, plasma is like the most common thing in the whole universe. 99% of the entire cosmos as we know them is plasma. Plasma means electrically charged gas. What happens if you consider literally the shell of our Earth, the very physics of that being changed in an electromagnetic way, not just the physical means? Remember how I said you can deal at the pollution level? Just take it at the simplest level, pollution. You're screwing up the sky. Follow the air quality standards law. Well, you can do this at the same level with breathing, okay? The more particulate matter, the more physical particulate matter in the air, the more of you that will die. This is just a fact. You go to the AMA and look it up. You're going to die if there's more physical stuff in the air. I am not speaking of just the physical level, but I am acknowledging that as a starting point. If that's where you want to start, fine. I am saying the ramifications here are much, much deeper in terms of what the impact is. Let's go to number 2, a fibrous material. Very unusual fibrous material. These materials are showing up over and over and over. They are submicron again. Normal fibers are on the order of 10, 7, 12 microns thick. You can see them with your eye, right? You take a wool fiber, you can see it. Those are in the order of 7, 12 microns, somewhere in there. A spider web, I got down to 2 microns. That's actually not true. Sorry, the spider web was 7 microns that I had, and asbestos fiber is on the order of 2 microns. Many of us are familiar with the environmental attention that has been given to the asbestos issue in our lives. Not a good thing to breathe. 2 microns, right? What if you have a material in the atmosphere that is measuring at the submicron level? This particular material was sent to the United States Environmental Protection Agency. It was sent with a very reasonable letter requesting permission, requesting identification for what this material was on behalf of the public interest. This was a claim of the letter. It was sent by certified mail. It was sent to the administrator of the United States Protection Agency. From my standpoint, a very reasonable request to make. If that I find something foreign in the environment, I look up the mission statement of the EPA, and I say, we may have an environmental concern, please identify. The EPA refuses, number one, they refuse to acknowledge even the physical receipt of that material. We have the letter to them, certified mail. They would not acknowledge the receipt of this material. There was simply no, they did correspond. They did write back. There was no reference at all to receipt of the physical material, and the response, you'll see a few choice words over and over and over, and those choice words are, we are not aware. We are not aware of any aerosol operations. They return the sample. Never did anything. They return the sample, and they state that it is not the policy of the United States Environmental Protection Agency to identify any unsolicited material. This was their response. What is policy? Policy is whim. Policy is a person in charge. Policy is not law. There are laws in place. There are mission statements of the United States Protection Agency. You don't get away with this with policy. The third category is that of biological components. Of what appears to be a desiccated erythrocyte. An erythrocyte is a red blood cell. Okay. What appears to be freeze-dried or desiccated. And I didn't see it once. I saw it over and over and over. There is a very solid basis of evidence that exists that indicates a extremely prominent biological aspect to these aerosol operations. I'm saying it mildly. It's quite conceivable. The information thus far suggests it very, very strongly. And that is that essentially every one of us or certainly at this point, let's be as conservative as we can, and let's say it certainly looks like the vast majority of those amongst us. Let's say, I got to say it direct, okay? And that is that we appear to be harboring and carrying a set of pathogenic forms in our bodies that, to the degree that I am able to conclude with my research, appears to have a direct tie with the aerosol operations.